Welcome students. In previous video we are learn about the different types of characteristics of DC machines, that is DC generators. Okay. In this video we are going to learn the leftover topics in our DC generator. In DC generator we are observe the characteristics. By seeing the characteristics, at no load current also there is a EMF is produced. That initial small EMF is called induced EMF. Thus induced EMF is obtained by residual magnetism. That's the point we are covered in our previous video. Now the condition for buildup of EMF in DC generator. What are the conditions for buildup of EMF in DC generators? So there must be some residual magnetism in the field poles. In field poles there induces a small initial EMF. We are observed in our characteristics study of DC generator in yesterday's video. So that small induced EMF is produced by what? By some residual magnetism. The field must connected to the armature such that the field current strengthens the magnetism. Field strength is depend upon the material of the magnetic. Sometimes EMF is not built up in our generator due to lack of residual magnetism. Residual magnetism, it is a magnetism. It is produced and stored by previous magnetism. Right. In case of series generator, the resistance of the external circuit should be less than critical resistance. So in this video we are coming into some important and new words, that is residual magnetism, critical resistance and critical speed. All those things are coming to picture, right? So have to know the meaning of these things. First, what is the case? Why the EMF is not built in DC generator? If the EMF is not built, then no torque, nothing, the machine gives no output. So what are the causes for non-buildup of EMF in DC generators? This is insufficient residual magnetism. If the magnetic is weak, then the storage of residual magnetism is not possible. Why this magnetism is like that? It is weak because of that, due to aging effect maybe. So that's why insufficient residual magnetism takes place. Due to insufficient residual magnetism, it induces an amount of small EMF. That EMF is due to this residual magnetism. If residual magnetism is very less, then it is very small. But it must be there in our machine to build up of EMF. If residual magnetism is not sufficient, then it will become a big problem. That's why we have to maintain our magnetism as very much strong. We have to give field strength for our magnetism to keep healthy. The magnetism is good, then only it is able to produce residual magnetism. Next, the next region is reversals of field connection. Reversals of field connection also coming to picture. If the field is reversed connection, it is just F and FF. It is symbolized as in our laboratories also. Here plus is for positive sign, minus is for negative sign. Like that, it is also some positive and negative connections like this thing is also appear. Field circuit is there. It sometimes we symbolize it as Z and ZZ. Z is connected to positive and ZZ is connected to negative terminal. Like that, F and FF. So in this context, we have to learn about the critical resistance and critical speed. These are the new terms in this topic. So what is meant by critical resistance? The maximum field resistance with which the shunt generator would just excite is known as critical resistance. Critical speed. The speed for which the given shunt field resistance represents critical resistance is known as critical speed. So by studying the definitions we are not able to understand. Just we go through these characteristics of DC shunt generator, then definitely you will get a little bit idea what is the critical speed and critical resistance, right? So this is the characteristics. Here OCC is open circuit characteristics. This is a curve shown in this diagram, right? And OP is a field resistance. Let's see. See, this is the open circuit characteristics, and this OP is the field resistance, right? A straight line passing through the origin. This is the field resistance, and this is the open circuit characteristics. Up to this thing we are already know. Now, to find the critical resistance, what you have to do? You have to draw a tangent line to the open circuit characteristics curve. Then we will get the critical resistance. Here OA is a tangent line. This OA is a critical resistance. Right, if we draw the tangent to this line, then see, we are observe the points here. This OS is a critical resistance. That critical resistance lines touches the open circuit characteristics by this tangent. If we drop a line perpendicular to this, if we draw a line, then this RT is there now, and R and complete S. So critical speed is equal to N1 into RT by RS. So how we will define this critical resistance by seeing this graph. Hence the value of field resistance represented by the tangent of open circuit characteristics is known as critical field resistance. Here our critical field resistance is OA, right? It is clear, critical field resistance. This is the field resistance. This is critical field resistance. Okay. Next point is critical speed. The speed for which the given shunt field resistance represents critical resistance is known as critical speed. It is represented with n suffix c, critical speed. So the tangent where it touches, here this is a tangent line, it touches the open circuit characteristics here. So at open circuit characteristics, this machine is rotate with some full speed of n1 rpm. Next, if the critical resistance touches this, at this the speed is changed. Nc is equal to n1. Critical speed is equal to n1 means full speed into RT by RS. This is the R. By this we are getting the critical speed. Here tangent line is important. This tangent line is critical resistance. That critical resistance touches this open circuit characteristics curve. Then we are draw a straight line here. This RS. The critical speed, the speed for which the given shunt field resistance represents critical resistance. That speed is called critical speed. Here OA is a critical resistance. NC is N1 into RT by RS. In previous section we are observed that if the field must connect it to the armature, there much see here this is a causes for non buildup of, if the field resistance is more than the critical resistance, then non buildup of EMF is takes place. Like that, the speed is less than the critical speed. See here at at n1 speed, this open circuit characteristics it is drawn. If we draw a tangent all those things, we are getting critical speed. If the speed is less than the critical speed, then buildup of EMF is not possible. This is a minimum speed. If the speed is less than this critical speed, then nothing is happened, no output. Like that, the resistance is there here. If the resistance, shunt field resistance is more than the critical field resistance, then it is impossible to build up of this EMF. These are the condition for build up of EMF in DC generators and some causes for non build up of EMF in DC generators. Okay. Let's see the conditions one more time. There must be some residual magnetism. The field must be strong, then only it will able to produce a residual magnetism. In case of shunt generator, if excitation on open circuit, its shunt field resistance should be more than a some certain minimum value of resistance. In case of series generator, the resistance of the external circuit should be less than the critical resistance. These are the conditions. Like that, causes is also there. For every cause, there is a remedy also there. What are the causes for non-buildup of EMF? That is insufficient residual magnetism, reversals of field connection, open and short circuit in field winding and armature winding. Field circuit resistance is, just now we are learning, the field circuit resistance is more than the critical resistance, or if the speed is less than the critical speed, the brushes not in proper position, or brushes not in properly contact with the commutator, wrong direction or rotation of armature. All those things are also causes for non-buildup of EMF. In this, the new words are critical speed and critical resistance. We already observed that. So what are the remedies? The direction of rotation must have been reversed. If speed is too low, then what we have to do? The remedy is generator should be rotated with its constant speed. Next, another cause, absence of residual magnetism. If the absence of residual magnetism is absent, then EMF will not generate. For this, what is the remedy? The remedy is a few dry cells can be connected across the field windings for 5 to 10 minutes to restore the residual magnetism. The machine can be run as a DC shunt motor for 10 minutes before it run as a generator. This is very good remedy. Same machine is operated as a generator and sometime it is operated as motor. Here, if the residual magnetism is absent, then what you have to do? The remedy is the machine can be run as a DC shunt motor for 10 minutes before running it as a generator. This is very good remedy. You have to remember this. Another cause. What is that? Short circuit. The short circuit like that occurs. Then what is the remedy? Remove the short circuit which may lie in the generator itself, the switchboard or in external circuit. Next, if open circuit in the armature, test and repair for open circuit if possible. And see, this is the next point. The field resistance is more. High resistance in the field winding causes also non-buildup of EMF. So what you have to do? The high resistance in the field circuit will not allow the generator to build up its normal voltage. So reduce it from the field circuit. If wrong corrections or wrong direction takes place, then reverse it connection. These are few remedies. In all those, the important one is absence of residual magnetism. If residual magnetism is absent, then a few dry cells can be connected across the field winding for 5 to 10 minutes to restore the residual magnetism, or the machine can be run as a DC shunt motor for 10 minutes before running it as a generator. These are the remedies. Right? Up to now we are studied some conditions for build-up of voltage and some causes why non-build-up takes place. For every cause we are deal a remedy also. Next, if we move to forward topics. In this mean gap, we are learned the two new words, that is also critical field resistance RC and critical speed. The value of field resistance represented by the tangent to open circuit characteristics is known as critical field resistance. Like critical speed, the speed for which the given shunt field resistance represents critical resistance is known as critical speed, n suffix c. So these are the topic. Next move forward to the next topic is parallel operation of DC generator. Parallel operation of DC generator. So what are the necessity of parallel operation of DC generator? Why it is required? Already generators is also there. Single generators is there. Instead of using that single generators, why we connected some parallel generators at a time, then we operate for our service continuity. Why? What is the necessary? See, necessity is the mother of the invention for everything. So let's know what is the necessity of parallel operation of DC generator. First, to obtain the continuity of service. If we are using just a single unit, then if any repair or anything occurs, then it will shut down. There is no continuity of service takes place, right? Instead of using that single units, if we are using the parallel operation, then we are having so many advantages. Okay, let's see what are those. To improve the efficiency of the plant and maintenance and repair is more convenient if three generators are parallel at a time. If one of the generator is having some repair, the remaining two will continue the service. The third will repaired or some work is going on. Otherwise, if it is replaced with new one, whatever it may be, the continuity of service, it is the complete unit is not shut down. So continuity of service will takes place with the help of the remaining two. That's why maintenance and repairs is more convenient. Next, if we want to install few more generators, then additional generator can be installed very easy as required. Because of that, this is of parallel connections. And to improve the life of generator, here by this parallel operation, the load is shared equally. That's why no burdens on the single unit is not occurred. So it improves the lifespan of the generator and it improves the plant capacity also. Like this, so many necessity of parallel operation is there. And main reason is why this parallel operation is takes place. Because of that, it's depend upon the load required condition. If we deal with more load, generator can be put into operation according to the load requirement. When the load of the generator is more than its capacity, then additional generator is connected to in parallel with this load, right? This is about the parallel operation necessity. Mainly, these parallel generators are shared equally, right? Shared equally these loads. Next, these are the main reasons. So parallel operations are coming into picture. Next, what are the conditions for doing a parallel operation? We have to follow some rules to connect this parallel operation. So what are those rules? That is the conditions for. The polarity of the parallel generator should be same. The terminal voltages of parallel generator must be same, and the characteristics of parallel generator must be identical. They should have good dropping characteristics. The no load and full load should be same. Mostly shunt generators are widely used for this parallel operation. Parallel generator should have same percentage of voltage regulation. Here polarities must be same, terminal voltages of parallel generators must be same. Next, characteristics must be identical, and parallel generation should have same percentage of voltage regulation. They should have drooping voltage characteristics, and they must be same speed at no load or full load. These are the conditions. This is important and it comes under a short answer question also. What are the conditions to connect our parallel operation of DC generator? First of all, what is the advantages of this parallel operation? That is necessary. We are already covered. The advantages is continuity of service can be achieved and efficiency of the plant can be increased. Maintenance and repairs is also more convenient, and additional generators can be installed as when required. The life of the generator can be increased. Because of that, no extra burden takes place. Load is shared equally. The capacity of the plant can be increased. Generator can be put into operation according to the load required. When the load on the generator is more than its capacity, then the other generator will share the load. That's why it maintains some stability and the lifespan is also increases. These are the main reasons. These are the main advantages for our parallel operation. This is a parallel operation. Here positive terminals are connected to and negative terminals are connected at end. So these are the connections. Here an additional equipment is also used, that is equalizer ring. Equalizer ring is used to equalize the load current on the DC generator and make parallel operation stable. It is made with some heavy copper bar or conductor. So we have to maintain having less resistance. So what is the purpose of this parallel operation? By using this equalizer rings. This is a parallel operation. Here we are observe only two generators like that. So many units are added depend upon our load capacity. If the load is more than its capacity, then the other generator will have to share that load. Depend upon the requirement, additional generators are also used. This is a parallel operation. equalizer ring. This is made with copper with having less resistance. Right. During the parallel operation of series or compound generator, the induced EMF are unequal if then a circulating current flows in the series field winding. This circulating current may causes short circuit. This results damages of the generator. This circulating current can be prevented by connecting equalizer bars with the inner terminals of the series field generator. That's why we are connected that equalizer rings. Mainly it is used in case of what? Compound and series generators. This is an important bit in your competitive exams also. Sometimes it is comes in your short answer questions. What is the purpose of this equalizer rings? The main reason is due to unequal induced EMFs, some circulating currents flows in the series field windings. This circulating current may cause some short circuits or it results in some damage of the generator. This circulating current can be prevented by using this equalizing rings or equalizer bars. It is made with heavy copper bar or it having very less resistance. Right. This is about the equalizer. Next, what are the applications of these generators? We have studied the characteristics of different types of generators, separately excited, shunt, series, compound, like that. Generally, DC generator is used for lighting and power supply purposes or for charging the batteries. Next, DC series generator. DC series generator nowadays plays a very much important role. It is used in complete traction and railway systems, arc lighting, series incandescent lighting, and series booster, special purpose like supplying field current for regenerative braking of DC locomotives used for constant current source. In railway coaches and locomotives tractions, DC series generator plays a very much important role. DC series generator is also called as booster. It is used for constant current sources in electronic circuits also. Next, DC compound generator. This compound generator having two types, cumulative and differential, like that. Level compounding, over compounding, and flat compound also we are observed. In this, level compound generator are used to maintain constant voltage in DC distribution network. Over compound generator are used to offset the voltage drop in feeders. Next, cumulative compound generator are mainly used in electrical lighting and power services and electric railways. Lastly, differential compound generator is used in arc welding. Right. This is about the DC compound generators. Next is DC separately excited generators. The DC separately excited generators are used in emergency power supply, mainly in hospitals, operation theaters, some very much important cases. The uninterrupted of power supplies are necessary in these cases. At those conditions, this emergency power supply is needed. At that case, this DC separate excited DC generators are used. Speed control of generator is in Wadley node system. Also, this separately excited are used. Sometimes it is used as exciters. Exciters means to excite the field. We have to maintain its magnetism. Permanent magnets are available up to some extent only. So we have to maintain electromagnetism. It is we are observed in previous classes, right? So here to maintain that electromagnetic as a magnet, we need as a exciters in large alternators. At that cases, these separately excited DC generators are used for the excitation of field purpose. So DC separately excited generators are used as exciters or excitation for a large alternators. It is used for a large alternators. These are the different applications, and so many applications is also there. These are some of the applications, right? Next, the next topic is welding generators. This is one of the application of DC generator, right? Here the generator used for welding purpose have voltage dropping characteristics. We are using differential component generator here. Already I just told to you, and this is a brush. Here differential compound is used in arc winding. No, this is one of the application, right? Let's see what is the application. What is used for this arc winding? This is a welding generator. Here we are using a differential compound generator. It is having voltage dropping characteristics. By varying the shunt regulator, generator voltage and current values can be adjusted to the required levels. This is the shunt regulator. This is a shunt regulator. By changing this, by moving this, we are adjusted. Here this is a differential compound. Two fields are there. One is a shunt and another is a series field. See, this is the shunt field and series field. Both are opposite with each other. That's why voltage dropping characteristics are takes place. And armature. See, in this ammeter and voltmeter, 2 meters are used. By adjusting this shunt regulator, the current values and voltage values can be adjusted to the required level. This is a circuit diagram for welding generator. Mainly, this is a good application for differential compound generators. Every time the shunt field and series field are opposite with each other, so the voltage dropping always takes place. Due to that voltage dropping characteristics, this is called differential compound. If the cumulative is there, then these two fields are having same direction. It aids with each other, then cumulation is takes place. Here the difference of this EMFs will adjusted. Because of that, these two are in reverse opposite directions. Right. See, this is a electrode connected to here. Electrode and arcing. Some iron piece, metal piece is there. By using this arcing, we are weld these metal pieces. This is about the welding generator. Let's see an example problem. Right? Up to now, we are learning about the shunt. Okay. Shunt generator. Series and cumulative generators are there now. In that, an example about shunt generator. Just question is that a shunt generator delivers 450 amperes at 230 voltages, and the resistance of the shunt field and armature fields are 50 ohms and 0.03 ohms respectively. Calculate the generated EMF. Here IL is equal to load current is given as 450 and terminal voltage V is equal to 230. RSH is equal to 50 and RA is equal to 0.03. These are the given data. They are given. Okay. Our question is what? To find the generated EMF. Okay. Here IA is a combination of IL plus ISH. We know the IL value only. We don't know the value of IA. So IA is equal to what? Combination of IL plus ISH. IL we know that is given as 450. What about ISH? ISH is equal to, here this is the ISH, this is RSH. V by R. This V by RSH gives this ISH value. Right. So V is equal to 230 they are given. RSH 230 by 450 gives 4.6. IA is equal to IL plus ISH according to KCL. Here this is the junction. No? It is going as this. So IA is equal to IL plus ISH. 454 plus 4.6 is equal to 454. Right. Armature voltage drop is equal to IA into RA. By multiplying this, we getting 13.6 voltage. So EZ is equal to what? V plus IA into RA. It gives the total voltage. This is the problem. Right. This problem is about a shunt generator. In our given data, they are given as 450, voltage 230, RSH, RA. We don't know the value of IA first. EG is formula of what? V plus IA, RA. Our intention is to find IA value. IA is combination of what? IL plus ISH. Okay. ISH is equal to what? V by RSH. V. they are given V by RSH values. By simply substituting that, we are getting ISH. After getting this ISH, we add this ISH plus IL gives the IA value. Simply substitute the IA value in our formula. Then we are getting this. This is very simple problem, but every time routinely comes in our question paper also. We will see some more example problems and do some example problems in the solved problems available in your textbooks also. So many problems are there. This is an problem related to separately excited DC generator. N1 they are given 1200 rpm, 200 supplies 200 amperes current, 125 voltage. What will be the load current when the speed is dropping to 1000? Okay, they are given N1 and N2. So this is the relation for this problem. E2 by E1 is equal to N2 by N1. By using as previous model, we are find the value of E1 here. So we know the value of N2, N1 and E1 also. We don't know the value of E2. By substituting this, we are getting this value simply. This is the problem on speeds. Like that, so many models of problems are available. Okay, you have to solve this. Okay, so in this video we will learn some causes of non-buildup of voltage and what are the conditions for buildup of voltage and critical speed, critical field resistance, and what are the advantages of this parallel operation of generator, necessary of parallel operation, what are the conditions for parallel operation, the parallel operation circuit, equalizer rings, and the applications of this so many variety wide ranges of these generators. And we are studying one more application, that is welding of DC generator by using differential compound machine. All those things are learned in this video, right? This is your second part, and this is about the generator. We have solved some problems in these videos. You have to solve more problems. You have to practice more problems in your textbooks also, right? This is about your DC generator parts in your DC machines. From the next onwards in our DC machines, we have to move forward to DC motors topic. In this first unit and second unit, you will learn about the DC generators. After that, DC motors are there in the next section, right? Thank you for watching this, and expect more problems you have to solve.